Hi friends, in this video we are going to discuss about capacitor split phase induction machine. How we can add the capacitor? If capacitor added in the main winding, its reactance reduces. That's why don't add capacitor in the main winding. Generally, this is main winding which should have high reactance, right? That's why the capacitor should be added in series to the auxiliary winding. Capacitor should be added in series to the auxiliary winding. And here generally we have a rotor circuit, and here we have a single phase AC supply given to the machine. My main winding and my capacitor, here the condition is that the capacitance XC, capacitor reactance should be greater than the reactance of the auxiliary winding. Capacitor reactance should be greater than the capacitance of the auxiliary winding. See here auxiliary winding, main winding, XC, and the what is this? The switch, centrifugal switch. Right. Now the capacitor added in series to the auxiliary winding. Now generally if we draw here, for example, this is my voltage V. Now here the main winding current is lagging to the V. Which is theta M, and the auxiliary winding current is, can you tell me? Auxiliary winding current lagging to the voltage or leading to the voltage? Yeah, exactly, leading, because here XC is there. That XC is greater than XA. That XC is greater than XA. That's why this is in leading. Now this angle is theta A. Now, generally we know torque is directly proportional to sine theta. Where theta is the angle between theta M, IM and IA. Theta is the angle between IM and IA. See here theta value is very much greater than previous two methods. In resistor split phase, theta is here itself. In inductor split phase, theta here itself. But in capacitor split phase, the theta increases enormously. When theta increases, sine theta increases, then torque also increases. Generally in resistor split phase, inductor split phase, capacitor split phase, in these three, which is more preferable? Capacitor split phase is more preferable. In these three, the capacitor split phase is more preferable because the torque, the theta is very high. That's why torque also very high for this machine. Right. Now, can you tell me theta is equals to now? Now theta is equals to theta M plus theta A. Theta is equals to theta M plus theta A. Now let's draw here. Let's see here. Theta is equals to theta M plus theta A. That is, theta is equals to tan inverse of Xm by Rm plus tan inverse of Xc minus Xa by Ra. This is my theta. Theta is equal to tan inverse of A plus tan inverse of B. How we can Newtonize this equation? Tell me. Then theta is equals to tan inverse of A plus tan inverse of B. That theta is equal to tan inverse of A plus B by, or A minus B by 1 minus Xm by Rm into Xc minus Xa by Ra. Actually, this is plus. Now, this is the equation. Tans of A plus tans of B is equals to tans of A plus B by 1 minus AB. Whatever, this is finally our theta. This is finally our theta. Here, we should remember that the capacitor added in series to the auxiliary winding, and this is my theta. Generally, up to now, we already done in resistance split phase and inductor split phase, and now in capacitor split phase. Now the question is that, now they are asking the question, very important, question is very important. Generally, to get the maximum torque, how much XC should be added in the auxiliary winding circuit? To get maximum torque, how much XC required to add in auxiliary winding circuit? In auxiliary winding, this is the question. To get maximum torque, how much capacitor reactance required to add in auxiliary winding? To get maximum torque, nothing but when theta is equals to 90 degrees, then we can get maximum torque. To get maximum torque, nothing but the theta should be 90 degrees. Then only we can get the maximum torque. Right? Let's substitute here theta is equals to 90. Then find out this XC. Now this is your time. Substitute this theta equals 90 degrees and find out the XC value and tell me. Let's do it. Hold the video and do it. Substitute this theta is equals to 90 degrees, then find out XC. Now fast, do it. Yes, have you done? Tell me the answer. Generally, I placed your theta is equals to 90 degrees. That is equals to tan inverse of some Xm by Rm plus Xc minus Xa by Ra divided by 1 minus Xm by Rm into Xc minus Xa by Ra. When this comes here, here tan 90 degrees is equals to, do you know what is tan 90 value? Infinity. Generally, if this is infinite, we can't determine this value. So, this can be written as sin 90 by cos 90. Tan 90 nothing but sin 90 by cos 90. What is sin 90? Sin 90 1, cos 90 0. 1 by 0 nothing but infinite. Yes, the same. So, here Xm by Rm plus Xc minus Xa by Ra divided by 1 minus Xm by Rm into Xc minus Xa by Ra. Yes. Now do it cross multiplication. When we done cross multiplication, 1 minus Xm by Rm into Xc minus Xa by Ra, this value into 1 and this value into 0. So what is final? 1 is equals to Xm by Rm into Xc minus Xa by Ra. Xc minus Xa by Ra. This is 1. When comes to here. Now I want XC. For that, first see here, Xc minus Xa by Ra is equals to, which comes here, Rm by Xm. Right? When this comes to here, Rm into Ra by Xm. Completed. Now I want XC, right? XC is equals to RA RM by XM. When this XA comes here, plus XA. This is very important. Very important. Previously they asked 2 times in GATE. XC, the capacitor reactance to get the maximum torque, is equals to RA RM by XM plus XA. Okay, if you have an idea of this equation, you can get answer within seconds. If you don't have an idea, you have to solve this all in your GATE exam. It will take nearly 5 to 10 minutes. Just remember this one. XC is equals to RA RM by XM plus XA. That is the reactance, the capacitor reactance to get the maximum torque. To get the theta is equals to 90 degrees. This is the value. Right? So this is generally the equation problem. Let's see this one, and I will give you one question. How we can do? Let's see. I will give you one question on this one. Let's see. Now my question. A single phase 50 Hz induction motor. A single phase 50 Hz induction motor. Single phase 50 Hz induction motor. The auxiliary winding resistance. The auxiliary winding resistance 10 ohms. Auxiliary winding resistance 10 ohms, and main winding resistance 5 ohms, and main winding reactance 50 ohms. Main winding reactance 50 ohms, and auxiliary winding reactance 4 ohms. Auxiliary winding reactance 4 ohms. The given question: single phase 50 Hz induction motor, auxiliary winding resistance, main winding resistance, auxiliary winding reactance, main winding reactance. Then find the required capacitance to get maximum torque. Then find the required capacitance to get maximum torque, or how much capacitance we have to add in the auxiliary circuit. This is the question. What is that? A single phase 50 Hz induction motor, RA and XA, RM and XM. Then find the required capacitance to get maximum torque. Tell me the answer. Hold the video and do the question solution and give me the answer. Very important. Right? Hold the video. Do it. Are you done? Right. Let's see. Let's check it. How many members done the correct answer? Let's check it. So generally, the people finding this one in generally, XC is equals to RA. What is RA? 10. 10 into what is RM? 5. 5 divided by what is XM? 50, and plus what is XA? 4. So what is answer? XC is equals to, these two gets cancelled out, and 1 plus 4, 5. Actually 5. XC is equal to 5 ohms, and the option A also 5 ohms in your question paper. Generally people putting the option A, and generally I done very well. I got the correct answer. But this is not the final answer. What I asked here? Capacitance. But you done only for XC. I want capacitance, you know. This is not a capacitance. This is the capacitive reactance, sir. This is not a capacitance. But I want the capacitance value. You should remember this one. So XC is equals to 1 by omega C, nothing but 1 by 2 pi F into C. I want C. So C is equals to 1 by 2 pi F into XC. 1 by 2 pi f into xc. Now tell me what is the answer. 1 by 2 pi f, 2 pi f into xc. What is the value? C is equals to 1 by 2 pi f. 1 by 2 pi f value 314 into 5. So xc is equals to 1 by 1500 5 300 1500 and 10 5s are 50 and 5 4s are 20, nothing but 70. So 1 by 1570 farads. 1 by 1570 farads. This is 100% correct answer. This is not a correct answer for my question. If he asked you find the capacitive reactance, you can put the answer 5. This is 5 ohms. But I asked you capacitive reactance, 5 ohms. If I asked you capacitance, this is answer 1570. 1 by 1570 farads. Be careful. This is very important. Okay, this is generally the question. In single phase induction machine, there are only 2 possibilities of questions. One question to find out the capacitance or capacitive reactance. One question. And second question, they will give you same question. They will give you same question. Let's see here. They will give you same question. And they will ask you the motor or the rotor rotates in. The rotor rotates in which direction? Rotor rotates in which direction? In which direction? This is the question. Tell me, the rotor rotates in which direction now? Now you have to find out Xm by Rm and Xa by Ra. Right? Tell me what is Xm by Rm. My Xm is 50 and my Rm is 5. And my Xa by Ra, my Xa is 4 and my Ra is 10. Nothing but this value is 10. Nothing but this value is 0.4. Nothing but 10, 0.4. Here 10 is greater than 0.4. Xm by Rm is greater than Xa by Ra. That's why the rotor rotates in clockwise direction. The rotor rotates in clockwise direction. If Xm by Rm is greater than Xa by Ra, the rotor rotates in clockwise direction. We know that. These are the only 2 questions in single phase induction machine they will ask you in problems. In theory, many questions are there you can do. But in problems, we have only 2 types of questions. One is the direction and another one is the required capacitive reactance or required capacitance. Capacitive required and the direction. These are the only 2 problems, the possibilities in single phase induction machine especially. Right? Let's see. Okay, next. The capacitor split phase. Capacitor split phase induction motors are 3 types. I already told you. In that first one, Capacitor-Start induction motor, and second one, Capacitor-Run induction motor, and third one, Capacitor-Start and Capacitor-Run induction motor. Capacitor-Start induction motor, Capacitor-Run induction motor, Capacitor-Start and Capacitor-Run induction motor. In this, see once the diagrams. See once the diagrams. Here single phase AC supply, and here the auxiliary winding and the capacitor and the centrifugal switch and my rotor. This is the capacitor added. This is Capacitor-Start induction motor. And Capacitor-Run induction motor, see this, the Capacitor-Run induction motor. This is Capacitor-Run induction motor. Capacitor-Run induction motor. Nothing but there is no need of centrifugal switch. The centrifugal switch, there is no. This is in operating also acting, starting and in running condition. Capacitor start and capacitor run. How it will be? The capacitor start and capacitor run. Capacitor start and capacitor run. Single phase AC. And here my auxiliary winding. And here I have two capacitors. One for starting nothing but which having the centrifugal switch, and another for running nothing but there is no centrifugal switch. These are the three types of capacitors: start, capacitor run, capacitor start and capacitor run induction motors. Right. Generally out of these three, which having highest starting torque? Out of these three, this having highest starting torque. In this machine, the starting torque is equals to 3 to 4 times of the full load torque. 3 to 4 times of the full load torque. And next one, here capacitor used to increase the starting torque. Here capacitor used to improve the power factor. Here capacitor one is used to increase the starting torque and another one is used to increase the power factor. Like this. Okay, so like this they are generally we are using capacitor start, capacitor run and capacitor start and capacitor run induction motors. What are the applications of these motors? What are the applications? Generally these are used for fans, blowers, wind blowers, fans, wind blowers, and also refrigerating systems, and also these are used for generally, and also these are used for washing machines, refrigerators, fans, blowers, and low rating reciprocating pumps, reciprocating and centrifugal pumps. These are the applications of single phase induction motors. These are the applications of these capacitor start or capacitor run etc. induction motors, fans, blowers, refrigerating systems, washing machines, low rating refrigerating and centrifugal pumps. Generally these are low rating refrigerators and centrifugal pumps, nothing but small 1 HP motors generally used for domestic applications. In domestic applications, water pumps sump to the like a building upsides like that. Generally, which are used in domestic applications, small motors, which are small, low rating reciprocating pumps and centrifugal pumps. This is simply about the capacitor start, capacitor run, capacitor start, and capacitor run induction motors. These are one of the type of special machines. Okay, whatever. This is about the single phase induction machine. The very small topic, single phase induction machine. In that, first double revolving theory. In that equivalent circuit, the formula for backward torque and forward torque. Next, cross field theory, nothing but split phase induction motor. Split phase induction motors are three types: resistance split phase, inductor split phase, capacitor split phase. Capacitor split phase again three types. These are capacitor start, capacitor run, capacitor start and capacitor run. And here we have only two problems. I already told you. One is the direction and another one is how much capacitance we require. If they may ask you how much resistance we require to get,
how much inductive reactance we require to get. You have to do the problems for those. Right? This is about the single phase induction machine which is completed, and also this is one of the special machines also. Right? This is now completed, the single phase induction machine.